Hi everyone, this is Asma Mushtaq from the EEVIBES. So this is the second part of the same problem that I discussed earlier, but now we will see the time analysis on the MPLAB software. But before that, let's just have a quick review of it. We came to know that this program takes 76 microseconds overall, where 37 microseconds were required for forwarding the value 55 hex into the port B and then introducing the little delay. All right, and then overall then what happened, we forwarded or we copied the value which is equal to a hex, fine, and then we send that value on the port B with a little delay. Okay, so 37 for this, 37 for this, 74, and then two machine cycles were used for this instruction, which is equal to the go to instruction. That's why 37 plus 37 plus 2, which is equal to 39, and overall 76 microseconds were required. Now moving back to our program, what we need to do, we can go to the debugger, and in the debugger you can go to the settings where you can set the frequency, crystal frequency for your program. Right now we are using 4 megahertz crystal oscillator, so I'll just click on OK, fine. Then you can go to the debugger again and open the stopwatch as well. So this stopwatch has many different portions. You can see, you can calculate the total simulated cycles, instruction cycles, as well as the total time used in this program, fine, or how much time it takes. And you can also notice the crystal frequency is also mentioned, which is 4 megahertz in this case. So I'll not the run now program by just clicking on the run button, but instead of that I will click on this step into button. The step into button actually goes instruction wise and lets know how much time the program is taking. So when I'll click on the step into button, you can see the one machine cycle is used while executing the one instruction, which is the move literal value to reg 055, while the program counter is pointing to the address of the next instruction to be executed with this green sign, fine. So it takes one machine cycle. Then again step into it, you can see two machine cycles. Now the next instruction is call delay, fine, and we know that it takes two machine cycles, so that's why you will notice over here the machine cycles will become 4. So when I will step into it, it becomes 4, and the control is also transferred at the delay label, fine. And in the delay label, the first instruction is move literal value to reg. So let's just start it. One machine cycle, two machine cycle, 3, 4, 5, and see branch node 0, since the count value is equal to 5, so that's why when you will step into it, it will go back. So one time loop is actually run. Now we will just keep stepping into it and we'll count how many times the loop is running. So 2 times, now 3, 4, and this is the last time the loop should run, 5. And you will see it will go to the return now. See, after completing the 5 times count, it went to the return instruction, and when it goes to the return instructions, the control should be transferred to the next address from where the control was actually transferred, fine. So see, until then you can notice 37 machine cycles are used, which are exactly equal to what we evaluated, fine. Then we will again step into it and we will see that 1 and then 2 machine cycles, and we again came back to the delay routine, and we will see how many times it will run. 1, 2, 3, 4, and 5, and then see it will go back, and then overall 76 machine cycles are being used for running this program completely. Thank you for watching. And also one thing more, since the time was equal to 1 microseconds, so that's why 76 microseconds are required for running this program completely.